All right, now we need to talk about something called the alternating series remainder theorem. And if you want to just see what the alternating series remainder theorem is, it's right here. It looks like that. But I think we need to work up to that. I don't think that's where we need to start. So let me give you this series and we'll talk about it a little bit. All right. So this series from 2 to infinity, -1 to the n power over n factorial looks like this. 1/2 minus 1/6 plus 1 over 24. I'm doing factorial, so that number is, for example, 4 factorial, which is 24. Minus 1 over 120, you get the idea. Okay? Now, this alternating series converges, but I don't know what it converges to. I have no idea at the moment. All right? Don't know. But it does converge. Now, in my earlier videos, I talked about how you know if an alternating series converges. This one converges. Okay, now I don't know what it converges to, but it converges to something. So what's our notation for the number that a series converges to? It's capital S, okay? And so I might wonder, let's think about some questions. How close is the sum of the first two terms to S? And how close is the sum of the first three terms to S? I don't know that number, but I can add these together, okay? And how close is the sum of the first four terms to S, all right? So, okay, just think about that. Now, why would I ask questions like this? Isn't it true that the more terms of the series we add together, the closer we're going to get to S? That's how it works. If this series converges to some number S, then the more terms of the series I add together, the closer I'll get to that. That's how it works if a series converges. That's what it means to converge. All right, so I wanted to get you thinking about that. Now let's look at it in a little more detail. Okay, so here's my same series, right? Here's how it's going to work. The sum of the first two terms minus S, that means that's the difference between them, absolute value is going to be less than the third term. So it's like the sum of the first two terms, how close does it get you to S? You know, when I subtract, that's how different they are. How close does it get you to S? It'll get you less than this close. That's the third term. You see a pattern here? The sum of the first three terms minus S is less than the absolute value of the fourth term. Remember, S with a subscript, that's the partial sum. A with a subscript, that's a term. So that's why I can say S2 minus S. Well, this needs to be the third term. Okay, 1 over 24. S3 minus S. This needs to be the fourth term. So 1 over 120. Okay, so you get the idea. You see a pattern. S4 minus S is less than the absolute value of A5. That's the fifth term. So S4 minus S is less than 1 over 720. That would be the fifth term. So I could say this. I could say, well, the sum of the first four terms gets you really close to S. All right? Why is that? Because if you subtracted them, the absolute value of their difference would be less than 0.001. That means they're real close to each other. All right? Okay, so that's how it works. I want to show you a pattern. All right, you see all these statements here. You see a pattern to them. And these just tell me how close a partial sum is to whatever the series converges to. All right? Now, can you look at that and see why I'm saying that S4 is really close to S? If you subtract them and take the absolute value of their difference, you're going to get that number. That's real small. That means they're really close together. All right? Okay, so in general, here's what the remainder theorem says. The nth partial sum minus the sum is going to be less than an plus 1. That's just the next term. The sum of the first n terms versus the term after that. Okay? Like the sum of the first two terms versus the third term. The sum of the first three terms versus the fourth term. That's all that this says. Okay. So let's do this. Let's do some thinking and maybe take an example where we prove that that's really true. Okay, so I'd like you to be able to do something like this. Can you take this alternating series right here and verify that that kind of statement's true? You know, just to give you an example, this would be true. The absolute value of the sum of the first 5 terms minus s has to be less than the absolute value of the 6th term. That's like all those examples I was just showing you. Can you verify that? Meaning, can you calculate every single number here and prove it's true? Okay? Well, sure, we could do that. That wouldn't be so hard. The sum of the first 5 terms, S5, is just the sum of the first 5 terms. I took this series, 1, 2, 3, 4, 5. There's the first 5 terms. I combine them. That's the number I got. All right? Now, what's S? S is whatever the series converges to. This series happens to be a geometric series. It's an alternating series, but it's also geometric. The first term is 1, and R is negative 1/4. So it converges to 4/5. That's 0.8. Now notice, before I go any further, adding the first 5 terms together is already getting me pretty close to that number it converges to, all right? Okay, then the 6th term of this series is negative 1/1024, okay? All right, so is it true? Now I just want you to verify this. Just do the calculations and prove it's right. That's all I'm asking. So I found every number that's involved in this statement from the alternating series remainder theorem. All right, there it is. There's S5. There's S. Absolute value of the 6th term is 1/1024. Okay, the 6th term of the series. And so if you do the math, it says 0.0078 is less than 0.0097. It's true, right? It's a true statement. Is this number less than that number? Okay. All right. So hopefully if we do that and we calculate every number, you have a context for, you know, seeing like, what is all this stuff right here? Well, okay, that's the sum of the first 5 terms. That's whatever the series converges to, and this is the 6th term, all right? Okay, so hopefully, you know, this allows you to see the numbers and gives you a context for that. All right, so let's do a question like I know that you'll see in the homework or the test or, you know, whatever you're doing, okay? Question might go something like this. The wording might be slightly different, but it'll sound something like this. How many terms of this series right here, and what I mean is the least number of terms, are needed to approximate the sum with an error of less than 0.4? So what we're saying is the sum is what? Capital S. Saying this series converges to some number capital S. Okay, I don't know what that number is though. But yeah, I know it converges to something. So here's what we want. We want to figure out how many terms do you need to add together, which partial sum minus the actual sum minus the number it converges to is going to be less than 0.4. That's what we mean by error, meaning these two things are going to be different. But if you subtract them, you're going to get this number called the error, all right? So we want to find out how many terms do we need to add together so that when I subtract these, it's going to be less than 0.4, okay? Now, that looks a lot like this, doesn't it? Okay, it's the same thing. So I guess I could figure out how many terms to add together or which partial sum it is if I found the first term of the series that fell below that number. So look, here's the series, here's the terms, all right? These are not the partial sums, these are just the terms. The first term of the series, for example, is -1. The second term of the series, for example, is 1/√2, right? These are just the terms. When I'm looking at the terms, I notice there's the very first term that in absolute value falls below 0.4. That means that we want to take the partial sum up to that point, all right? See how they're just one apart? S5 minus S, for example, is less than A6. That's the first unused term in the partial sum. The partial sum went up to the first 5 terms. The 6th one was the first one that was left off. So I need to take the partial sum up to that point right here. My answer, S6. That's it. That's the answer. How many terms at minimum are needed to approximate the sum with an error less than 0.4? 6 terms. S6 is our answer. Okay? All right. Now, you can take that at face value and not question it, but I do think it'd be good if I pointed out why. Why is that? Why do I come to that conclusion? Why did I bracket this? Why did I say that this was the error term? Take the partial sum up to that point? Well, the alternating series remainder theorem would say this. S6 minus S is less than A7. A7 is the first term that's less than that. Okay? That's why we do it that way. Okay, so in general, that is like a corollary of that alternating series remainder theorem. If you want to approximate the sum of a series with whatever desired error is, like whatever that number happens to be, you can look at the terms and find the first one that falls below that and take the partial sum up to that point. That's what you do. So I boxed lots of things here. I always want to commit to one final answer. And there it is. Our final answer would be 6 terms or S6 or the sum of the first 6 terms.